Let's continue looking at domain and range of functions from graphs, and let's look at a couple more exceptions. So the first one that you want to think about is what are called vertical and horizontal asymptotes. And an example, let's say that we're given the graph and we want to find the domain and range. So you're given a function. If it's a vertical or horizontal asymptote, often it's represented by a line. So this line here would be 1, 2, 3, 4, 5. That's y is equal to 4. So let's say that we had the function here and that looked like this. And then you had another function that looked like this. So you have to be careful about reading this. What this means is this is 1, 2, that's x is equal to minus 2. The dotted line suggests that this graph gets closer and closer and closer, in this case from both directions, but it never actually reaches minus 2. And the horizontal line, y equals 4, means that there's a vertical asymptote, there's a horizontal asymptote at y equals 4, so this line gets closer and closer to y equals 4. In this case, in both directions. It is possible that you would have something that looks like this, so it approaches a horizontal asymptote for only one perspective. And now what we're going to do is we're going to look at domain, and we're going to look at the x values, and we're going to say what can x be and what can x not be. If you notice, and we'll do it with the graph, is x can be everything from minus 2 more positive and minus 2 more negative, but it is never negative 2. So there's two ways to write this. One way you can write this is you can write, actually there's three ways to write this. You can write r, but then semicolon, x is not equal to minus 2. So the way to read this is domain is all real numbers, but x is not equal to a negative 2. An alternative way of writing that would be that x is greater than minus 2 and x is less than minus 2. And that means exactly the same thing. Now let's look at the range here. The range, if you notice the range, first of all, it never goes below y equals 4. The question is it ever equal to y equals 4? Well, the definition of a horizontal asymptote is that you get closer and closer to y equals 4, but you never actually reach it. So this would be y is greater than 4, but strictly greater than. The only problem with that we've done that exactly right, except for, notice this point right here. This is what's called a bubble or a hull. Its formal name is a removable discontinuity. If you notice here, x is also not equal to 2, 3, 4, 5, 6, 7. X is not equal to minus 7. Y is not equal to 1, 2, 3, 4, 5 there, but it is equal to 5 there, so it doesn't affect the range. It does affect the domain. So now the domain actually gets fairly complicated. If you write it in this notation, you would simply write domain is all real numbers. X is not equal to minus 2. X is not equal to negative 7. So that's not too hard. If you would write it in the alternative notation, it would be a little more complicated. That would be everything. And in this point, you'd probably want to switch and not use this notation at all, but rather use interval notation. And that's why you see, even though interval notation seems to be a little more difficult at first, we typically use it because it's much more flexible and supple. So let's write domain and range both. Domain here is all real numbers, not 2 and not 7. in interval notation, that would be from minus infinity to minus 7, from minus 7 to minus 2, and then from minus 2 to infinity. And there's going to be an and sign between all of those, or if we use set notation, a union symbol. If we want to do range, the range would be everything from 4 up except, actually that's it. The range is simply everything from 4 up. So we can start at 4 and we go to positive infinity. And that's how you'd write domain and range there. And that's how you do domain and range of using graphs with horizontal and vertical asymptotes. Let's do another quick example there. Let's do one in which here's your y graph and here's your x graph. Let's have a horizontal asymptote at y equals 2. And let's look at a graph that looks like this. Domain here, let's look at domain. You think, what can x not be? Well, x can be just about everything here. So, well, not even just about, it can be everything. So here it's just all real numbers. Now range is a little bit more difficult. Range can be everything below minus 2, but there is a minimum here. So what you really need is you need a minimum point. And if you don't have a minimum point here, you're not going to be able to do this. But if you can read that minimum point off, so that's the point 1, 2, 3, 4. That's minus 4, and 1, 2, 3, minus 3. So if you notice, y can be everything between negative 3 and positive 2. So if you're doing range in terms of, so it's between minus 3 and positive 2, and it can be a minus 3, but it cannot be a positive 2. How would you write that in terms of interval notation? Let's do that, the same thing in interval notation. All real numbers in interval notation just means everything from minus infinity to infinity. Now let's look at range. Range, you write the most negative number first, that's a minus 3. That's going to be a bracket, or what's called a closed parentheses, because it includes minus 3. And it's not going to include 2, so that's going to be an open parentheses. Domain is everything, so it's just all real numbers, or from in interval notation, negative infinity to positive infinity. The range is everything, let's just look at that. It's everything from minus 3 to a positive 2. It includes the minus 3, but it doesn't include the positive 2. So we write that in interval notation as close bracket minus 3, comma, 2, open parentheses. And that's how you do domain and range from a graph.